Hi class, this is section 3.4, constructing angle bisectors. As you can see, we start this section with a conjecture, angle bisector conjecture. If a point is on the bisector of an angle, then it is blank from the sides of the angle. So hopefully you remember from chapter 1, your definition of an angle bisector. It is a ray that divides another angle into two congruent angles. So let's go into Sketchpad and make an angle bisector. So I'm going to start with 3 points, and our definition of an angle is two rays that share a common endpoint. So I'm going to construct a ray, and then I'm going to construct another ray that has that same endpoint. So we've made an angle. Now I want to bisect this angle, so I'm going to highlight it, and I'm going to say construct angle bisector. Now we need to name it, so I'm going to give these points some letters, so angle ABC. Then I need to put a point, I'm going to drag that over there. I'm going to put another point on the angle bisector itself. Okay, so the question in the conjecture is, what's the relationship between the point on the bisector and its distance away from the sides of the angle? So what I am going to do now is highlight this ray and highlight point D and construct a perpendicular line. I am going to make another point that is the intersection point between the perpendicular line and the side of the angle. I am going to construct that as a segment because I don't want that whole line showing up, and I'm also going to measure its length. So I've measured the length of ED, knowing that this is perpendicular. Okay, I'm going to hide this line. So all I can see is that segment and its length. And then I'm going to do the same thing with the other side. I'm going to move point A a little bit out of the way, but you can see as I pull A, that perpendicular segment moves as well. So I am going to highlight the ray down here and point D, and I am going to say construct perpendicular line, and I'm going to do the same thing. Find that point that is the intersection point. I can name it. Make it a segment, measure its length, and then you can hide the perpendicular line. What do you notice about the length? No matter where I put D, it is equidistant to the sides. I can make my angle smaller and the length stay the same, or I can make it large and the length stay the same. Okay, so ED is equidistant, or ED is the same length as DF, and point D is equidistant from both sides of the triangle. So I am going to highlight this angle down here and measure it. Then I'm going to measure the other part. So we know that ray BD is an angle bisector. I can use my pen and put congruent tick marks. Don't want that. Okay, to show that they're congruent, and then I'm going to mark ED congruent to DF. Okay, we can write ourselves a little note here that ray BD is an angle bisector and is equidistant from both sides of the angle. Okay, you can copy and paste that into your notebook to go along with conjecture 8. And now we can fill in the conjecture. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So put me on pause and make sure you get that into your notebook just like you want it. The rest of the video is going to be spent constructing an angle bisector with your compass and straight edge. So you can find those notes on my website for bisecting an angle. So we are going to do this by using our compass and straight edge. So you start with any angle. Put your compass point on the angle's vertex. In this case, that's vertex Q. Set the compass to any convenient length and draw an arc across the angle. You can make it continuous there if you want to, not pick it up. Now it doesn't matter the width of your compass. You can change the width, but you're going to put your pinpoint on one intersection point and put an arc on the inside of the angle. And without changing the width, you're going to do the same thing coming from the other direction. Now you'll connect your vertex to the point of intersection of the two arcs, and you have constructed an angle bisector. Notice the markings on your angles. Just like with the other video, if you scroll down, it'll take you through step by step. So you want to take your time and make sure you know how to construct an angle bisector. And I would like for you to do number 10 on page 160. I will check that in class tomorrow, and we'll see you then.